Hello there. Welcome to Mr. Roche's Flip Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. This is my accomplice Wilson. I'm Mr. Roche. Today in this video we're going to be doing Systems of Linear Equations Part 2, which is about solving systems by substitution. First I'm going to be demonstrating how to solve a system using substitution, and then we'll be learning how to make up a system from a story problem. So here we go. Here are the steps that we can solve when we use substitution. First, we're going to choose to solve one of the two equations for one of its variables. One of the equations, one variable. Substitute the expression from step 1, so whatever expression we get for that one variable, we're going to substitute into the other equation that we didn't modify. Then we'll solve that single variable equation using basic math from grade 9, and then we'll substitute that solution into either of the original equations. We can verify by substituting that same solution into the other original equation, and if we get the same answer, it must be right. So here's what it looks like. First, I'm going to choose one of these equations to solve for one of the variables. Well, here I really have nothing to do because this equation is already solved for y. Come to think of it, so is this one. This is as easy as a system as you can possibly get because they're both solved for y. If this y equals this and this y equals this, then this must equal this. That's the basics of an equation. Okay, so we have 5x plus 7 equals negative 2x minus 2. Okay, that expression equals that one. So now I'm going to shift my variable terms to one side, my numerical terms to the other, and solve it. So I have 5 x's, bring that over as plus 2 x's, bring that over as minus 7 and minus 2. That's 7 x's equals negative 9. X equals negative 9 sevenths, or negative 1 and 2 sevenths. So that's the value of x. So my solution is going to be an ordered pair, a value for x and a value for y. My x is negative 9 sevenths. Okay, now I have to find out my y value, so I substitute this value for x into either of these. I'm going to put into the first one. Choose a different color so it's not confusing. So I have y equals 5 times x, negative 9 sevenths, plus 7. Okay, now if I simplify this, there's nothing to reduce, so I just have to do this multiplication. Y equals 5 times negative 9 is negative 45 over 7 plus. Now to add 7 to this is going to be difficult because we don't have a common denominator, so I'm going to change the 7 wholes to 49 sevenths. Keeping in mind that 49 sevenths is 7 wholes. Okay, now the addition is a little bit easier. Y equals negative 45 sevenths and positive 49 sevenths is positive 4 sevenths. So that's my value for y. Now, I can verify this by substituting this same value for x into this equation. Okay, so there it is into that equation. Let's solve. Negative 2 times negative 9 is 18 over 7. Minus, instead of 2 wholes, I'll call that 14 sevenths. And now 18 sevenths minus 14 sevenths is 4 sevenths. Same answer. I verified it. It must be right. Let's try a more difficult one. This one, both equations are in standard or general form. So now I'm going to choose one of these to solve for one of the variables. I'll choose this one, and I'm going to choose to solve for x because that looks like it's the easiest thing because it's almost down as x already. I just have to move that over. So that one I'm going to solve for x. Oops, daisy. x equals negative 4x. Sorry, I lost my mind for a moment. The hair got in the way. Okay, so I brought this over as negative 4y, so there's the same equation as this, but it's just solved, written for x. So now that I know that x is this value, I'm going to replace this x in that equation with that expression. So here we go. 2 times negative 4y plus 17. Okay, so that's in for here. Minus y equals 7. Now I have a single variable expression that I can solve with basic algebra. So here we go. This is negative 8y plus 34 minus y equals 7. Okay, now I can combine my y's. That's negative 9y's equals. Bring this 34 over as minus 34. Negative 9y equals 7 minus 34 is negative 27. And now I can divide each side by negative 9. Y equals 3. So my solution, my y, is equal to 3. I still have to find out what my x is. So I'm going to substitute this value for 3 in for either of those y's. Okay. Hopefully I left myself enough room. I'm going to put it in for the top one. So we have x plus 4 times y, or 4 times 3, equals 17. So that's x plus 12 equals 17. That's x equals 17 minus 12. X equals 5. Okay, and to verify, let's also put this value for y into this equation. So we have 2x minus 3 equals 7. So that's 2x equals 7 plus 3. 2x equals 10. Divide that by 2 and x equals 5. Same answer. It's been verified. Okay, now for a more difficult one still. Okay, I'm going to change, I might as well just keep the same routine going. First equation for the first variable. I'll write this one for x. So that is 4x equals, that comes over as negative 3y. Of course, I don't have to put plus or minus 0 at all. So, now I'm going to solve for x. So I have divide side by 4. X equals negative 3/4 y. Okay, so now I'm going to replace this x with this value of x. So here goes the substitution now. 8 times x, negative 3/4 y, minus 9y equals 5. Okay? Before I go multiplying this and dividing, if you look close, I've got something I can reduce top and bottom. So 8 and 4 reduced down to 2 and 1. 2 times negative 3y is negative 6y's minus 9y's equals 5. Okay, I can simplify that to being negative 15y's equals 5. Divide that by negative 15. I have y equals negative 1/3. So that's the y solution, negative 1/3. Okay, let's put that same value, or let's put that value for y in either of these equations for y. Let's put it in this one. 4x plus 3 times negative 1/3 equals 0. I can fix that up a bit. In fact, really easy. These cross off to 1's. So I have now positive and negative 1's, which is minus 1 equals 0. That's 4x equals 1, if that comes over as plus 1. And then divide that by 4, I have x equals 1/4. There it is. Okay, let's just make sure. We'll also put that value for y into this equation. 8x minus 9 times negative 1/3 equals 5. This reduces 9 and 3 down to 3 and 1. So now I have 8x, I have negative 3 times negative 1 is positive 3. That's 8x equals 5 minus 3. 8x equals 2. Divide side by 8. X equals 2/8, which reduces to 1/4. It's verified. Okay, that brings me to the second part of the video, and that's about making up a system from the story problem. So, here's the first question. A store sells 2 different lengths of moldings. Moldings are those things that we use for our baseboards or crown moldings. The longer is 8 feet less than twice as long as the shorter one. Together, one of each of the moldings totals 22 feet. What are the molding lengths? Okay, so we're going to set up a system that'll help us solve that. Now, what we have to do is look for the clues. There's going to be 2 statements there that will allow us to write the 2 equations. So let's see. The longer is 8 feet less than twice as long as the shorter. That's one big long piece of information. Okay, well, let's let the longer and shorter ones be something. I'm going to let the longer be L. I could let it be X and Y, longer and shorter be L, doesn't matter. Shorter be S. We just have to be careful that S doesn't look like a 5. You're welcome to use X and Y in here instead of L and S, as long as you know what each letter represents. Okay, so the longer is 8 feet less than twice as long as the shorter. Twice as long as the shorter would look like this. 8 feet less than twice the shorter would look like this. Okay, so there's one equation. Now the other equation says, together one of each totals 22 feet. So one length plus one shorter equals 22 feet. And that is the system that I can now solve using substitution or possibly by graphing. Okay? And we'll learn another way next video called by elimination. One more example. Some of you will find these ones tough because they deal with money. Okay, it says Billy's piggy bank contains 44 nickels and dimes, so there's 44 coins. The value is $3.40. Determine how many of each coin Billy had. Well, first of all, I can deal with $3.40 just the way it is, but then I have to deal with the value of nickels and dimes as dollars, which would be, nickels would be $0.05 and dimes would be 0.1 or 0.10 dollars. If you don't want to work with decimals, deal with cents. So a nickel's worth 5 cents, a dime's worth 10 cents, but then this would be 340 cents. I think that's easier. So one equation would be that 5 cents times the number of, well, let's give some variables first here, sorry. We'll let the nickels equal N, and the dimes, we're going to let those be D. Okay, so 5 times the number of nickels will give me the value of nickels in cents, plus 10 times the number of dimes will give me the value of dimes in cents, equals 340 cents. Okay, so that's one of our equations. The other one, so that's using the values of the coins. The other statement is going to be using the number of coins. We know that the total number of coins is 44, so the nickels plus dimes is 44. Nickels plus dimes equals 44. So there's our system right there.